Doing question 5, this is B and C of this part. So in B, it wants you to use the data they give below, so the standard reduction potentials for the reduction of copper 2+, H+, or hydronium, and the nitric acid. They're giving you all the standard reduction potentials in those cases there, and they want you to explain why copper metal dissolves in nitric acid, but not in hydrochloric acid. So in this case here, let's start with the nitric acid because that's the one we've already done in the last question. And I'll point out here, it's written down, the balanced equation, but it's written down in terms of just H+, but we know that doesn't really exist. It's actually H3O+. There should be an additional 3 waters on this side as well. But that doesn't change anything regarding the numbers over here. So in that case there, we're going to do the copper nitric acid couple. Now, if you think about it, copper is being oxidized in that case, right? So that's happening at the anode. So if we're looking just at that reaction, the oxidation of copper, that's going in this direction up here. That means I'm going to change the sign over here. So our E naught is actually going to be minus 0.34 volts if I'm writing it in this direction. I know this is not an equation, but we're saying that it's oxidized, it's going in that direction. Part of that, so the other side of that, is my nitric acid is being reduced, and that happens at the cathode. So that one there is happening in that direction, and so its value is going to be 0.96 volts. So I could add these together. I put them in the proper order or switch the signs as needed. So your E naught of your cell, in this case here, ends up being 0.62 volts. So this is spontaneous. Now you could have also calculated it a different way. You end up with the same answer because you're really doing the same thing. And that's, if you remember your equation, it's the cathode minus your anode, which is exactly what we did. We just put a negative in front of our anodes. We ended up switching the sign to get that. Either way you do it, it's fine with us. Now, if you want to look now at the copper and the hydrochloric acid couple. Okay, so in the hydrochloric acid couple, the chloride is not participating in terms of a redox, in a redox manner at all. So it's not being reduced. It's the H+ that is being reduced down to hydrogen gas. So our first thing that happens, our copper is getting oxidized. So that's our anode again. I want to use this equation here. And our E naught is minus 0.34 volts. Now our H+, or H3O+, is being reduced. So this would be our cathode. Our E naught is 0. That's our standard hydrogen electrode anyway, or the She electrode. So it's just going to be 0. You're adding these guys together. You see that you get an E naught cell that is negative, meaning that this reaction in this way is not spontaneous. Non-spontaneous. That's just kind of giving us that proof. So that's why it will not dissolve in hydrochloric acid, non-spontaneous, but it will dissolve in nitric acid because it is spontaneous. So part key to this question, get the right wording here, what other standard data could be used if you do not have standard reduction potentials? If you don't want to use electrochemistry in order to solve this problem, can we use potentially other thermodynamic data to tell us whether something is spontaneous or not? So think of delta G naught, right? You can tell if it's spontaneous, if it's negative. Right, so E naught has to be positive. As we just did in the last question, I didn't fully pull it out. So to be spontaneous, you need negative delta G or positive E naught. So we can potentially find these values if we have delta H and delta S of these reactions, which means we need to have available to us the enthalpy of formation data and absolute entropy values for each of the species in our reactions. And then yes, we can use those to calculate delta H, to calculate delta G, and depending on the sign, we could tell whether it is spontaneous or not, and we'll end up with the same answers in terms of it's spontaneous or not, and realize that that's why it dissolves in nitric acid and not in hydrochloric acid.